So in this video, I'm going to show you examples about 3 to about 7, and we're going to talk about how the coordinates of the unit circle relate to finding the exact value. So I'm turning the webcam off so you don't have to see the ceiling, and so that we can see the whole screen here. So if we're going to have, it says just find the point on the unit circle that corresponds to the real number. So I'm going to just go look for this on the unit circle. So I'm going to look for 3 pi over 4, and you've noticed that today we've made the complete transition into radian measure only. So 3 pi over 4 is there, and they just want me to write that coordinate out. So I'm going to write out negative square root of 2 over 2, square root of 2 over 2. Negative pi over 3. So either I have to add 2 pi, which is the same as 6 pi over 3, or I have to go negative pi over 3 this way. So I'm going to go 1 pi over 3. I'm going to make sure I look for a 3 in the denominator, and it's right there. So it would be the same as 5 pi over 3. And the coordinate there is 1/2 square root of 3 over 2. And then on this one here, 7 pi over 6, I'm going to find that one, and I'm going to just read the coordinate right off the graph. So negative square root of 3 over 2 and negative 1/2 would be my coordinate there. Now what they're asking me to do in this one is they want me to actually find the sine, the cosine, and the tangent of that angle measure. So I'm going to look for the sine of 2 pi over 3, the cosine of 2 pi over 3, and the tangent of 2 pi over 3. So the sine, I'm going to go to 2 pi over 3. I'm right here. And the nice thing about the coordinates method is I don't have to worry about the sine anymore because it's already in there. So I don't have to do that extra check like I had to do with the triangles. So the sine, remember, is the y coordinate. So this is the sine of 2 pi over 3. It's square root of 3 over 2. The cosine is the x coordinate. So again, this is the x coordinate. So I've got negative 1/2. And then the tangent, remember, is the sine divided by the cosine. So I'm just going to take my sine, square root of 3 over 2. I'm going to divide by my cosine, negative 1/2. And we have our little shortcut that we learned earlier. I'm going to get rid of my 2's. So I've got negative square root of 3, or I could do square root of 3 over negative 1, or I could just do negative square root of 3. Both of them are acceptable. In example 7, it wants me to find all 6 trig functions for 7 pi over 4. So I've got to find the sine of 7 pi over 4, cosine 7 pi over 4, tangent 7 pi over 4. I'm going to put their reciprocals next to them, cosecant 7 pi over 4, secant 7 pi over 4, and cotangent of 7 pi over 4. All right, so let's look for 7 pi over 4. 7 pi over 4 is right here. So this is the coordinates that I am using. We know the sine is the y coordinate. So I've got negative square root of 2 over 2. For the reciprocal, we could just flip it and we would get negative 2 over square root of 2. Not likely that that's going to be one of our answer choices. That is a perfectly good acceptable answer. However, we kind of have to reverse the rationalization process here to get that radical out of the denominator. So it's going to be negative 2 square root of 2. Square root of 2 times square root of 2 is just going to be a 2. And these cancel, so negative square root of 2. So then we're going to look at 7 pi over 4. And you'll notice it's square root of 2 over 2. This time it's positive. And then when I flip it, it's going to be this. Well, guess what? When I rationalize, it's going to be exactly the same as this one, except that it's going to be positive. So I'm not going to do all the steps. I'm just going to skip to square root of 2. You're going to start recognizing that this is the same as that. This one here is actually the same as this. So you're going to you'll probably start recognizing some of those patterns. All right, 7 pi over 4. Remember, I need the sine divided by the cosine. So the sine is negative square root of 2 over 2. The cosine is square root of 2 over 2. You'll notice that those are exactly the same number except for the sine, so that's got to reduce to negative 1. And if tangent is negative 1, the reciprocal of negative 1 is still negative 1, so that also has to be my cotangent.